So let's go into graphing. Hopefully y'all are kind of gotten comfortable in how to solve equations. Really, it's just like I said, anytime you have an equation that has a log in it, all you want to do is take it out of logarithmic form into exponential, and then you can go easy from there what you need to do. So now for graphing, we want to start just like what we did with exponential functions. Let's list off our basic function first, and then we're going to list off all the transformations. All right. And I guess if you want me to, let me list off all your potential basic functions. For exponential, your basic functions could have been 2 to the x, or 3 to the x, or 1/2 to the x, or 1/3 to the x. Now those were all the exponential ones from last lesson. For this one then, all the basic functions you have a choice of is y equals log base 2 of x, or I'm going to go ahead and write it like this. How about log base 3 of x? Or y equals log base 1/2 of x, or log base 1/3 of x. So in all these cases, it's all about your base. Your base could either be 2, 1/2, 3, or 1/3. Your base could be 2, 1/2, 3, or 1/3. So if we go up to this problem, let's go right to our base to tell us what the basic function is. It's going to be y equals log base 1/2 of x. Okay, and everything else that's up there is actually going to be a transformation, and we want to go in order. In what you're taking the log of, so everything that will be in this parentheses right here is what's considered inside the function. And we always want to do that first. That's always your horizontal movement. You take the opposite. So a +1 is actually shifting left 1. Okay. Looks like that's everything else, but there's no number attached to the x, and there's no negative sign in there, so that's everything as far as horizontal movement. So now let's go outside the function to figure out what's left. We've got this negative as one thing, and we have 2 as another transformation. So which comes first? Well, anytime you're doing vertical movement, the order is distortions, which is stretching or reflecting, stretching or compressing, and then reflecting, and then shifting. So we're going to do the 2 first. So we're going to stretch vertically by 2. And then the last thing is we're going to take care of that negative sign, which is going to be reflect over. And again, this is all vertical movement now since we're affecting the y values. So vertical means I would have to go over the x-axis. Okay, so there's my 3 transformations. Let's start out with our basic function and the t-chart. Now, if there's anything I could really tell you out of today's lesson is the fact of anytime you want to graph a log, if you can remember this, to graph a log, actually take your basic function out of logarithmic form and put it into exponential form. Okay, so let me come down to the very, very bottom real quick and let me show you. So instead of trying to graph y equals log base 1/2 of x, do it like this. Go to your base, which is 1/2. Remember, go across your equal sign. So 1/2 to the y power equals x. This is really what you're going to look at when you're doing your t-chart. This is where you want to graph from, is from this part right here. And it's just going to make your life so much easier, because otherwise, if you go back to original basic function written like that, you're going, okay, what's the log base 1/2 of 5 if I don't have a calculator? How am I going to pick this out? So what this is saying is, since my base is 1/2, my exponent is now my y variable, what I'm going to do is pick my y's this time to be -2, -1, 0, 1, and 2. Always do this with logs. Anytime you're asked to graph a log, first step, take it out of log form into exponential and pick your y's. Find the x's from there. Okay, so let's plug in a y value of -2. So 1/2 to the -2 is telling you basically 1/2 squared, which is 1/4. Flip it because it's negative, so it's 4. 1/2 to the -1, flip your base to 2, and 2 to the 1 is 2. 1/2 to the 0 is 1, because anything to the 0 power is 1. 1/2 to the first is 1/2, and 1/2 squared is 1/4. Okay, so again, like I said, every time, always, always, always do this. All right, from there, we're going to incorporate some of our transformations. The first transformation says shift left, and that's all horizontal, so we're going to subtract 1 from all my x values. And the y values, we want to stretch vertically by 2. So I'm going to go ahead and multiply by 2. And if I want to reflect over the x-axis, it means switch its signs. So if I multiply everything in here by -2, it's actually going to go ahead and take care of everything and switch the signs for me. Okay? So let's do a new t-chart to show this last bit. Okay, so I'm going to subtract 1 from all my x values. So 4 minus 1 is 3, 2 minus 1, 1 minus 1, a half minus 1, and 1/4 minus 1 would be what? Let's see, 1/4 minus 1, which is 4/4. So that looks like it's going to be -3/4. Okay? And then I want to multiply all of my y values by -2. So 2 times -2 is 4. 1 times -2 is 2. And 0, -2, and -4. And since that took care of all three of our, basically our transformations at one time, all we have to do is graph this last one and we are good to go. Alright, so we look like we've got on the x going from, let's see, 1, 2, 3, and y values are going from 4 to -4. Okay, so we have the point 3, 4, 1, 2, 3, 4. We have the point 1, 2. We have the point 0, 0, -1/2, -2, -3/4, -4. Okay, so it looks like this graph is kind of coming up through here like this. But we want to be sure to see, is this really, this lower half here on the left, is it spreading out left, or what is it doing? Let's trace our asymptotes just like we did with the exponential functions. Now, the original log function in its basic form has the asymptote right here along the vertical axis, okay? So that's that line x equals 0. What we want to do is trace that throughout the transformation. So if I take this x equals 0 and I shift it left 1, so I move it over to here, it's really the line x equals -1. So I've moved it. If I stretch it vertically by 2, well, a vertical line stretched vertically doesn't really do anything, so it's still there at -1. And if I flip it over the x-axis, it really hasn't done anything. So we can still keep it there at -1. So let's come back in here and just draw in our vertical asymptote. And we'll title it x equals -1. And then we can go to our t-chart. Let's look at these x values sitting right here in the t-chart. They go from 3 to 1 to 0, so it's shrinking. It's coming left, 3, 1, 0, goes to -1/2, -3/4. It's getting close and close to -1, but it won't ever cross. So this right here is the graph of our function. All right, looks like we have our final example for this lecture. We want to graph one more time. Just practice doing this. So the first thing we looked at was the basic function. And then we wanted to list out all of our different transformations. So the basic function, let's see, transformations. Okay, the basic function is go to your base, log base 2. So it's going to be y equals log base 2 of x. And like I said, really in order to graph this, we're not going to graph it in log form, we're going to graph it in exponential. So 2 to the y equals x is really what we're going to be graphing. The transformations, let's list them in order. It's like coming up in here, everything that's inside that parentheses is what we are going to be looking at for my horizontal movement. Well, the only thing inside that parentheses is one is the negative and it's the 2, but let's list them out. When you're inside the function, you want to do shifting first, where there's no plus or minus numbers in there. We want to do reflecting next. Well, that's the minus sign, so we're going to reflect over the horizontal, so it'd be y-axis. Okay, the next thing is the stretching or the distortions, and that's going to be by 2. And remember, anything horizontally, you kind of do the opposite, so it's actually going to be a, I guess you want to say, a horizontal shrink. Because we're going to actually multiply the x values by the reciprocal. Always inside, always take the reciprocal of the number. Okay, so that's everything inside. Kind of do a little line. The only thing that looks like it's affecting outside the function, which is vertical movement, would be the -3. So we're going to shift down 3. Okay, let's do our t-charts. first basic t-chart's going to be off of this main equation right in here. Again, pick the y values, -2, -1, 0, 1, and 2, and plug them in. So 2 to the -2, 2 squared is 4. Since it's negative, we're going to take the reciprocal. It's 1/4. 2 to the -1 is negative, or 2 to the -1 is 2. Take the reciprocal, so 1/2. 2 to the 0 is 1. 2 to the first is 2, and 2 squared is 4. Alright, so from there, let's go to our transformations. First one says reflect over the x-axis, which means if I'm going to go, over the y-axis, so I want to go from the positive x side to the negative x side, so I want to switch all those signs to negative. And then I want to do horizontal shrink by multiplying the x values by 1/2. So let's combine those two together. If I multiply by -1/2, it does both. It flips it over the y-axis and it's going to shrink it horizontally. And then the third step would be to shift down 3. So I'm going to subtract, let's see, let's write this as, we're going to multiply by -1/2 here, but we're going to subtract by 3 for the y's to get our t-chart for that one. Our new t-chart. Okay, so multiply all of those x values by -1/2. So it'd be -1/8, -1/4, -1/2, -1, and -2. And we're going to subtract 3 from all of these y values. So -2 minus 3 is -5. -1 minus 3 is -4. Then -3. Then -2 and -1. So it looks like we have our final t-chart. Alright. 1, 2, 3, 4, 5, 6. And let's give ourselves some lines on the x-axis too. Alright, let's graph. -1/8, just slightly off of the x-axis or the vertical y-axis, and then we're going to go down to -5. Okay, and then -1/4 down to -4. Really close dots together. -1/2, -3. -1, -2. And -2, -1. So you can finally see a little bit of a curve kind of coming in here. Alright, so what is really happening with the asymptote with this? Okay, originally had an asymptote kind of right here at x equals 0. If I flip it over the y-axis, it doesn't move because it is the y-axis. If I multiply x equals 0, 0 by 1/2, hasn't really changed anything. It's still x equals 0. And if I move it down by 3, a vertical line shifted down by 3 is still the same thing. So it looks like our original our vertical asymptote is still going to be here at x equals 0. And there's the graph for that original function, log base 2 of -2x minus 3.